Okay, hello. This is my video for steps number 2 through 4 for our wind tunnel project that we've been working on. And so right here is the wind tunnel that I built for the last assignment, build the wind tunnel. And so you can see that here. And so since then I did steps 2 through 4, so I measured the cross-sectional area here. And so basically what I did was, because of the way my wind tunnel is built to match my fan, it's more of a trapezoid shape than an actual square, and so I had to take that into account. But when I did set it up and build it, I made sure that the entrance and exit were the same dimensions, so that made it a little bit easier. But basically I measured, so the top here was 32 centimeters, the bottom was 59 centimeters, and then each side was 43 centimeters. And I tried to keep all of my units in centimeters because my anemometer is set to measure in meters per second, and that's what the equations I had were for. And so I converted that all to meters after I calculated the cross-sectional area. And so basically I calculated the cross-sectional area of that trapezoid there, and it was the same for the entrance and exit. And then after I completed that, I took my anemometer here. Hopefully you can see that. And the fan's off because so you can hear me. But basically what I did is I took my anemometer and I divided this up into sections, and I took a velocity reading at each section here. And so the wind was strongest about here, and then down here at the bottom the fan has a base, and so that was a lot weaker, but it was still getting about 1 to 1.7 meters per second, and up here was closer to 4.7, and then here it was a little lower too, but better than at the bottom. And so I took 15 different measurements here at the entrance, and then at the exit here I did the same thing. So I went around to each spot and took a velocity reading in meters per second. And then you can see my calculations here at the top of my page. So these are the dimensions I measured up here for the trapezoid. And then I took those, and in step 3 I calculated the cross-sectional area for the entrance and exit, and those are in meters squared. And then I took all of those velocity readings, 15 for the exit and 15 for the entrance right here, and I averaged them to find an entrance average velocity of 3.7 meters per second and an average exit velocity of 3.1 meters per second. And then from there we were asked to calculate the volumetric airflow entrance and exit. And so this formula here with the red box is the equation for volumetric airflow. And so calculating that, these right here are the entrance and exit volumetric airflow readings. And then right here next to it I have the air mass flow readings. And so in order to calculate that, I had to look up the density of the air and then use our previous calculation for volumetric airflow, and running that, these are the results I got from that for the entrance and exit right here and right here. And then what I did at that point was compared with my group. So me and Dylan Kitchens have been working together a lot. We've been communicating back and forth and kind of comparing our results, and that's been kind of interesting because our setups are pretty similar, and we've actually been getting very similar results from our fan, which is a good sign that our calculations are correct so far. And then we've also been communicating with the drag tweens and their group, so that's Noelle and her group. And they've been posting in our discussion, and we've been communicating back and forth. And it's been pretty cool to see all the different wind tunnel designs. They've all looked pretty good to me, like they work pretty well. I know we communicated with Boyd as well in his group, and his wind tunnel. It was interesting to hear about his results because his setup's a little bit smaller than a lot of the others. So it was kind of cool to see some of the variation in wind tunnels and how we each have our results and we can compare those. But then the last part of this assignment, it wanted us to calculate the volume and mass of airflow loss, and that is obviously because they're made out of cardboard, and although I have taped the holes and things here and tried to make it as good as possible, there's obviously a lot of area on the wind tunnel where air could escape, and so there's going to be a difference there between the entrance and exit of the wind tunnel. And so what I did here was calculate the difference between the entrance and the exit for step number 4. And so I have right there, you can see delta airflow and then delta mass air. And you can see the results there. So it's interesting comparing those. Let me get it to focus. So comparing those results to other members of my group, to Dylan Kitchens and the other group we were communicating with, it seems like those are pretty close to the readings that they were getting for the loss in the volume airflow and mass airflow. And so I'll just zoom back here so you can see one last look at all the calculations for step 2 through 4. But it went pretty good so far. It was cool to compare my results with other members in the group and other class members. But yeah, that's it for these results. So thank you.